Hello everyone, and welcome back to my channel. If you work with next-generation sequencing data, understanding quality scores is essential for assessing the reliability of your sequence data. What are Phred quality scores? Phred quality scores are quality metrics used in DNA sequencing. They represent the probability that a base call is incorrect. The higher the Phred quality score, the more confident we can be that a base was called correctly. The Phred quality score uses a logarithmic scale, which means a small change in the score represents a large change in accuracy. The logarithmic relationship follows this formula. Q equals negative 10 times the logarithm base 10 of P, where Q is the Phred quality score, and P is the probability of an incorrect base call. Let's look at some common Phred quality scores and what they mean. A Phred score of 10 means there's a 1 in 10 or 10% chance the base call is wrong, giving us 90% accuracy. A Phred quality score of 20 means there's a 1 in 100 or 1% chance of an error, giving us 99% accuracy. A Phred score of 30 means there's a 1 in 1,000 or 0.1% chance of an error, giving us 99.9% accuracy. A Phred score of 40 means there's a 1 in 10,000 or 0.01% chance of an error, giving us 99.99% accuracy. In modern sequencing, Phred scores typically range from 0 to 41, with most good quality reads having scores above 20. When sequencing quality reaches Q30, virtually all of the reads will be perfect, with no errors or ambiguities. This is why Q30 is considered a benchmark for quality in next-generation sequencing. This R code snippet showed here prints a table that shows the probability of an incorrect base call for Phred quality scores ranging from 0 to 41. In the table, you can see the highlighted Phred quality scores that we have talked about in the previous slide. In FASTQ files, Phred quality scores aren't stored as numbers. Instead, they're encoded as ASCII characters to save space and make the files more compact. ASCII, or American Standard Code for Information Interchange, is a character encoding standard. The first visible printable ASCII character is the exclamation mark, which has a decimal code of 33. There are two main encoding schemes used in FASTQ files: Phred 33 encoding and Phred 64 encoding. In Phred 33 encoding, also known as by Sanger and Illumina 1.8+, we take the Phred quality score and simply add 33. For example, a Phred quality score of 30 is encoded as the corresponding ASCII character caret symbol. In Phred 64 encoding, also known as Illumina 1.317, we take the Phred quality score and simply add 64. This encoding has been fading out. Modern sequencing platforms mostly use Phred 33 encoding. Let's see how this works with a few examples. For a Phred score of 30, in Phred 33 encoding, 30 plus 33 equals 63, which corresponds to the ASCII character question mark. In Phred 64 encoding, 30 plus 64 equals 94, which corresponds to the ASCII character caret symbol. For a Phred score of 40, in Phred 33 encoding, 40 plus 33 equals 73, which corresponds to the ASCII character I in Phred 64 encoding. 40 plus 64 equals 104, which corresponds to the ASCII character H. A FASTQ file contains 4 lines per sequence, a header line starting with that contains the sequence identifier. The second line is the actual sequence. The third line is a line starting with plus that may contain the sum identifier or be empty. The fourth line includes the quality scores for each base in the sequence, encoded as ASCII characters. In the example shown here, the fourth line contains the quality scores. Each character corresponds to the quality score of the base at the sum position in the sequence line. It's important to know which encoding scheme your FASTQ file uses. Although modern sequencing platforms mostly use Phred 33 encoding, it's always good to check. To identify the quality score encoding of a FASTQ file, you can have manual inspection. If you see character I, it is Phred 64 encoding. If not, it is likely Phred 33 encoding. It is recommended to use bioinformatics tool to check the encoding scheme. FASTQ is a popular tool to identify the encoding. When analyzing sequencing data, quality scores help you filter out low-quality reads, trim low-quality ends of reads, make informed decisions about variant calling, assess the overall quality of your sequencing run. Many bioinformatics tools use these scores to improve the accuracy of their analyses. Understanding Phred scores is fundamental to working with sequencing data. They provide a standardized way to assess the reliability of each bus call and help ensure the accuracy of downstream analyses. Remember the key points? Higher Phred scores mean higher confidence. Scores are logarithmic. A score of 30 is much better than 20 FASTQ in FASTQ files. Scores are encoded as ASCII characters. Modern platforms typically use Phred 33 encoding. Here are the references used to generate the video. The links are also included in the description down below. If you enjoyed this video, make sure to smash that like button. It really helps out. And if you haven't already, hit that subscribe button and turn on the notification bell so you never miss a new upload. Your support means the world to me. Thanks for watching, and I'll see you in the next one.